Welcome learners for the MSc first year of the semester second. I introduce about the paper that is a optional paper is called as a differential geometry. Let us go started as a lecture first for the differential geometry. Okay, in this unit first, the first fundamental form and the local intrinsic properties of the surface. In this unit, we discussing about the curve, how to their dimension will be formed, or the intrinsic property how to show in this form, and the first fundamental form is generated. Okay, let us go started as the what is the content of this unit. First is the introduction, second will be considered as a definition of a surface. Surface is the most important part of the first fundamental form. Okay, next is the nature of the point on the surface. Fourth will be considered as a representation of a surface. All of this means the first introduction will be shown to how to the unit first will be generated, and of course in this unit is mostly depending on the fourth unit because this is the basic part of this unit. um, Means a differential geometry, this is your paper will be show as a fifth paper. Okay, optional paper will be contained in this introduction. First of all, show what is meant by surface. After that, some points will be given as a surface, and next is a representation of a surface, how to represent it as a surface in this form. Fifth will be considered as a curve on a surface. In means in this five part will be show all the points of the surface, means a basic concept will be clearing on the surface. Next will be go as a tangent plane and a surface normal. You know that this is the basic unit of a 12th, also to the BSc part of a mathematics, but in this form, that is a MSc, they will be discussing in the detailing form. Okay, this will be generally used as a your competitive exam. All other things will be generated in this form, that is the surface in this form. Okay, basic information clearing in this form. 7 will be considered as the general surface of a revolution. 8 will be considered as a helicoids. 9 will be considered as a matrix on the surface, means a first fundamental form. This is the most important part of this unit because clearing of the first part, third and fourth unit also considering as a second fundamental form, means if you getting as a basic information about this form, that is the first fundamental form, then second will be considering as a most easily to solving this problem. Okay, next will be considered as a direction coefficient on the surface. 11 will be considered as a families of the curves. Next will be orthogonal trajectories. 13 consider as a double family of a curve, and 14 consider as a isometric correspondence depending on this family of a curve for depending on the surface of this form. Okay, one by one step will be generated in this form, and 15 will be considered as a instinctive property of the surface. Okay, this instinctive property how to do getting as a better information about the surface and curve also. Okay, let us go started as the introduction part of this first unit. What is meant by a space? How to consider as a space to the curve form? As in the case of the space curve, introduce either as a intersections of the two surface, means two surface will be interact to the each other, or the intersection will each other to given with the parametric coordinate. We shall introduce some surface form, that is the E3, either implicitly by the given to the equation type A. Okay, if suppose that we given as a form, that is a parametric form will be generated, means a coordinate will be generating x y z equals to 0, or parametrically by expressing in the term of a x y z in terms of two parameters u and v varying to the domain. We shall make this two notation will be given, that is a x y z and u and v for this part. Okay, this is suitable for the equivalent relation that is given to the surface locally. We classified as the 2 points for the ordinary points and singular points. We take to the curve on the surface and explain how to the parameter will be generated to the form of the showing to the properties of a surface. That you know that the tangent plane at the point P and the surface normal at consider as a point P, we introduced a coordinate system at every point on the surface. This system R1, R2 and N consider to the form of the moving triad, that is a two form will be generated, T, N and B. They will be generated as a space curve. After introducing some content of this quadratic form, that is a direction coefficient will be generated. This will be generated as a quadratic form and isometric information. Okay, this is the introduction part will be showing to the consideration of these points. Okay, second point is what is the definition of a surface. Okay, we give the two different definitions on the surface and some a simple example will be given. Okay, definition will be considered. A surface is a locus of a point p xyz in E3 satisfying some restriction on the xyz, which is expressed by the relation on the type function f xyz function f consider as a xyz equals to 0. It means a surface is the local of the point p. If suppose we given as a any surface and we consider as a one point for the p, they generated as a xyz three coordinates for given to the point e3 is satisfying some restriction that will be generated if they converted as a function xyz equals to 0. The above definition implies that any points of the equation satisfied to the equation of this form, same as we consider as the equation function f xyz equals to 0 is called the implicit or a constraint equation on the surface. This implicit form of the equation described to the surface of this form and some restrictive condition will be uses to form. Means clearly show by the definition first of the surface, that is when we given as a one surface and they generated as the any points p on this surface, that is a p point generated x y z three coordinate x axis y axis and z axis. Then if we changes to the form, that means the formation will be considering as a point, that is a function will be contained at this xyz axis, then function generated f of xyz equals to 0. This is the first definition of this form. Next will be considered as a definition second. If the parameter uv takes the real value and vary over the some domain d, a surface is defined parametrically as. In this definition, we show that parameter will be generated u and v takes the real value, means u equals to 3, v equals to 5, any value will be given and some domain will be generated as d, then surface is a defined parametrically, that is a x equals to function of a uv, y equals to g uv and z equals to h uv. This form will be generated in this condition. Okay, where f and g and h are a single value continuous function, then x equals to function of a f uv, y equals to g of uv and z equals to h of uv, where f, g and h are the single value continuous function processing to the continuous derivative of the rth order. Then the parameters u and v are called as a curvilinear coordinate. uv is used to represent points of a determination u and v. Okay, this form will be generated to the function, that is a x equals to generated as a value, means if we given as a form x y z is given to the first definition, that is the points will be considering xyz axis. Okay, what we say, we given as a plane surface in any points, if we generated as the any points will be given to the surface, plane surface any surface will be given, first point will be generated as a point p, they generated as a three direction x axis, y axis and z axis. This is the x axis, y axis and z axis. This x axis generated as a function, that is a uv, they generated as a parameter for the real value. Okay, g considering as a uv same as a real value and z considering as a huv for the real value, and generated as a sum of the domain is parametrically represented as a x equals to function of a uv, y equals to g of uv and z equals to h of uv. Okay, where f, g and h are the single value continuous function processing continuous derivative of the rth order. Such surface are called as a surface of a class R. Okay, the parameter u and v are called as a curvilinear. This u and v is called as a curvilinear, is represented by the points u and v. Hence, we have the two method for the representation on the surface. One is the global representation by using the constraint equation and another by the parameters using UV over the domain. Okay. First definition is called as a global representation. First definition is called as a global representation, and second definition which will be expressed in the form that is the equation content generated as a domain. Hence, the questions naturally arise whether two methods are equivalent or the suitable represent. This is your basic information about the introduction of this differential geometry. Surface will be generated to the form. First introductory part will be considering, that is a introduction will be generated in the curve of a function as well as the form of the equation, that will be the two definition represented as a function. First and second definition. First definition is called as a global representation. They uses as a x y z axis by using as a one points surface on the plane P will be generated at the xyz axis. Okay. Second, same using in the form of the equation, parameter will be uses u and v by using as a domain. This is the definition will be considered.